Graphs of logarithmic functions, example 1. Consider the function f of x is log to the base 2 of x minus 2, take away 4. And the first thing we want is the domain and range of f. Now if I just very quickly sketch log to the base 2 of x, of course that's y equals. And we know for that the negative y-axis is an asymptote, and it will come up through 1 here. And so the domain for that one would be x is greater than 0, and the range will be just y is any real value. Now we know enough about graph transformations to know that this will move us 2 units to the right. So now the asymptote would be x is equal to 2. The minus 4 just moves it down by 4. That's not going to make much difference. It will make a difference to the x-intercept. We'll come to that later. But basically it's going to do this type of thing here. So for part A, we can say that the domain will now be x such that x is a real and x would have to be greater than 2. Just think about it. If you put anything less than 2 in here, you're going to end up taking the log of a negative. We know we can't do that. The range won't be affected. It's just going to be y is all reals. Now we've already discussed the asymptote. So the asymptote would be the line x equals 2. And the only intercept we're going to have is this one here. So if we have y is equal to log to the base 2 of x minus 2 take away 4, it crosses the x-axis when y is 0. So 0 is log to the base 2 of x minus 2 take 4. So log to the base 2 of x minus 2 would be equal to 4. Take the inverse function, which for log to the base 2 is 2 to the x. So that would leave us with x minus 2 on this side and 2 to the 4 over here. So x would be 16 plus 2 is 18. So this is actually going to cross here at 18. So 18, 0 would be the only axis intercept. I want to sketch the graph showing important features. I think I need a slightly better sketch than this one here. So y-axis, this is part C of course, is the x-axis. This is x equals 2. We know the shape is going to come up like this. We know it's crossing here at 18. And we might want to just put on a couple of extra points. So if x is equal to 3, for example, log to the base 2 of 1 is 0, take away 4. So we might, so log to the base 2, if we put in 3 there, so 3, negative 4 would be a point on the graph. We might even try another point a bit further on, but certainly I would put that one on, and that will probably do us. And now finally we want to find the inverse function. I think I'm going to need a bit more room to do that, so I'm just going to clear the screen. So we want to find the inverse function. So let's start with y is log to the base 2 of x minus 2 take away 4, and then we interchange x and y. So x is equal to log to the base 2 of y minus 2 take 4. And now what we need to do is make y the subject of the formula. So I'm going to have x plus 4 is log to the base 2 of y minus 2. And take the inverse function of both sides. So that's 2 to the x. So 2 to the x plus 4 would be equal to just y take away 2. Remember, they're inverse functions. And so that would give us y is equal to 2 to the x plus 4 plus 2. So finally, we should state that the inverse function of x is 2 to the x plus 4 plus 2.